Good morning, all of you. Today we will discuss reaction turbine. In earlier lecture, we have discussed about working principle of reaction turbine. Now we go for the types of reaction turbine. First type is radial flow reaction turbine, which is further divided into two parts, two categories. One is inward flow radial flow reaction turbine, radial, all are radial. Inward flow radial reaction turbine, outward flow radial reaction turbine. Then we will discuss mixed flow and axial. First of all, inward. What is the meaning of inward in reaction turbine? Inward means what? This is the blade mounted on the disc that is called runner. Runner. Here it is. Runner. These are the blades. This is the center. Now, inward flow reaction, radial reaction turbine. What is the meaning of inward? Here, inward means water coming outward to inward. That is water coming out from the outside to center, towards center. That is inward flow reaction turbine. Our outward flow radial reaction turbine is opposite of inward. That is water coming from the center and goes outward direction. That is in this direction. In this direction. Okay. This is radial flow, inward and outward. This is the basic concept of inward and outward. Again, we have different. There is radial. So in this turbine, inward or outward, in this turbine, water discharge at the outlet is always radial. That means perpendicular to that point. Or discharge is perpendicular to the outlet. That means water coming in this turbine, water coming from the outside and goes towards center. That means at this point, outward point, this point water discharge is 90 degrees. Water discharge is 90 degrees, so that is it called radial. Here, outward flow, same concept. Water coming from the center and goes to the outward direction or outside. So at the outlet, this is the outlet. At the outlet, water is flowing at 90 degrees. Water is flowing at 90 degrees or discharge is 90 degrees. This is the basic concept of inward flow radial reaction turbine or outward flow radial reaction turbine. Okay. First of all, we erase all these things. Now we have discussed Francis turbine. Francis turbine. Most important part, Francis turbine is a mixed flow reaction. Mixed mixed flow reaction turbine. Mixed type. This is mixed type. Compressed turbine is mixed type. Okay. Mixed means water coming, water coming at radially. Water coming radially and goes to and leaving from the turbine is axial. That is why it is called mixed. That is why it is called mixed. Radially inlet of the turbine is the flow is radial and outlet of the turbine is axial. So that there is combination of radial and axial, so that it is called mixed flow type. Now first draw the velocity triangle. Draw the velocity triangle. First of all, you have to erase all these things. Now draw the velocity triangle. Okay. This is our plate center. This is our center. Okay. This is our plate. Okay. Now because this is the reaction turbine, radially the flow is radial. The flow is radial. So one mistake. I'm telling in about I'm telling you just opposite concept. The flow is coming at the outlet is axial and goes to the leaving from the turbine radially. Okay, just opposite. Inlet is axial, outlet is radial. Okay, sorry, I was told you that just opposite. Inlet is radial and outlet is axial. Sorry, inlet is axial and outlet is radial. Okay, first of all use all these things. Okay, now draw the diagram. First of all, resolve this things. Sensitive. Water This is v1, where this is the striking velocity or absolute velocity of water. This u1, u. So this is the u. So taking the u velocity vector is a small. This is the blade velocity. This is the absolute velocity of fluid or water. So u is small. This is u1 at the. This is the closing vector. This is